through the GITA and ASPRS website. So pass it along to friends, spread the word around. Lots of good stuff to come from us from both Kevin Gamble's and Ed Freeborn, who are both longstanding ASPRS members and working in the UAS field, and our star, our main attraction today, Mr. Pierre LeRoux. Pierre is the Director of Primary Data Acquisition Unmanned Systems Division at ASPRS, which is the American Society for Photogrammetry and Remote Sensing. ASPRS has been around since 1934 and do all kinds of great stuff as far as photogrammetry and remote sensing. We're at GITA trying to strengthen our partnership and move forward in some joint efforts such as today's webinar. Pierre is also the Vice President and Director of Geospatial Intelligence Solutions and Unmanned Systems at Quantum Spatial. These solutions integrate a wide array of sensor information and communication technologies to geospatially enable business processes, operations, decision support systems serving end-user markets that include energy, oil and gas, and emergency response. They've worked with BT to integrate intelligence, surveillance, remote sensing, and geospatial information. And Pierre has provided consulting and leadership on the selection, acquisition, coordination, and deployment of appropriate surveillance, GIS, and remote sensing technologies, as well as ISR tasking, collection, production, exploitation, and dissemination processes, TCPD, throughout the Deepwater Horizon spill response, NRDA, and restoration phases. Prior to joining Quantum Spatial, he was with Global Land Information Solutions at Intergraft. He was the manager, and Assistant Surveyor General and Founding Director of the National Center for Geospatial Information and Analysis, NCGIA, in South Africa, and the lead Geosystems Division of Intergraft Corporation Sub-Sahara Africa Distributor. Pierre has a Bachelor in Science and Survey Engineering from the University of Pretoria in South Africa, with an attached major in Computer Science and a Master of Science of Management degree from the University of Alabama in Huntsville. He's also, most importantly, a professional registered land surveyor. And by way of thought here, I heard a talk by Dave Minkle from the National Geodetic Survey a few years back that said GIS without geodesy is a crime. And so in bringing this webinar to you, it's real easy for GIS folks to go buy a hobbyist drone and throw it up in the air and collect some data and what have you. But that may not necessarily be the best approach. We may not know the rules of the road and all the cool stuff that needs to go on behind the scenes when it comes to photogrammetry and surveying and things like that. And so we felt this was an important topic to bring to our members. There's a lot of confusion, a lot of questions with UAVs and whatnot. So I'm passing control over to Pierre, and without much further ado, we will bring him live. I will unmute him. Hang on, sorry, Pierre. Let me get you unmuted real quick, and he can take it away and dazzle us with his presentation today. Pierre, can you hear us?
Thank you, Talbot. You're setting the bar quite high. Can you see the screen with the presentation on it?
Yes, sir. You're good to go.
All right. Thank you all. Thanks for the kind opportunity here for ASPRS to collaborate with GITA on this topic. And as you see, the title of the presentation here is Introduction to UAS and Geomatics. And the assumption that Talbot and I made in putting this together was to not assume that the audience were uniformly experts in either UAS or Geomatics. So we are going to cover these topics at the introductory level today, and there are plenty of opportunities for us to follow up on a more detailed level here.
If I can jump in for just a second, a couple of quick rules for the road. Again, to remind folks joining us, please put your phones on mute And you'll see up at the top of the webinar, you can bring up a chat window. If you have a question you'd like posed to Pierre, please send it to me as a message in the chat window, and I'll be sure to bring it to his attention at the end of the presentation. Thank you.
Okay. I'd like to thank, nobody knows everything here, and we have a huge support community at ASPRS, in government, academia, and the private sector that help us put these things together. And on the call here today with me are a few of my cohorts here, one of them being Kevin Gamble, and the other being Ed Freeborn, Greg Stensis, and Bruce Quirk from the USGS, and a lot of folks, Michael Hauk, all chime in and help us put this together. So, what are we going to do today? We've got the presentation split up into about five sections here, if you will. Briefly covering ASPRS. Then we'll cover an overview of unmanned aircraft systems. We'll go through a few use cases and examples at the high level. We'll talk about the FAA topic, and we'll provide a brief summary at the end. Now, I also need to lay down some thoughts here. When we talk about the FAA today, it's important to note that I am not an attorney. None of the folks that I work with are attorneys. We are not here to pick the FAA apart or comment in any negative way on what they try so hard to do. When we talk about the FAA today and the rules of the road that exists, it's merely a presentation of fact as it exists today, and we'll get into that a little more. So the objectives, of course, are to give you a perspective of UAS with some geomatics underpinnings. And of course, at the end of the day, we all want to use this technology. So we'd like to offer some pragmatic approaches to utilization and some thoughts for you to think about as you think about the possibilities here. And of course, ASPRS and GITA are excited to work together. All right. Let me just do some organization here at my end. Okay. Excuse me. Right, so what do we do at ASPRS? Our website is asprs.org. We have a UAS-specific URL, which is uas.asprs.org, on which you will find a glossary. That glossary you can consult as we go along today or in the future if you come across terms that I'm using in the presentation. So, we do believe that UAS solutions for mapping and remote sensing are here. It's a given globally and within the U.S. However, the time frame is dependent on the finalization of the applicable regulations by the FAA, not only the FAA, but ICAO and our state governments and so on and so forth. And we assume that in the long run, we won't have any legislation and regulation that will prohibit the safe and pragmatic deployment of these technologies. And when we talk about UAS, we talk about that, and I'll highlight this throughout the presentation, as additions to an existing portfolio that are already being used for mapping and remote sensing. It is our mission to move geospatial information science and technology and the application thereof forward as a holistic enterprise, where we recognize the interdependence among the academic, the public, and the private sectors in this whole arena. So at ASPRS, what we try and do is to simultaneously attempt to maximize the scientific, societal, and commercial benefits that can be realized by from geospatial information going forward. And we're trying to prevent a balanced view of this. So, all right, so what do we do? Talbot kindly already mentioned the conference that's coming up in Reno. The website for that, again, is uasreno.org. There is a second conference that is as important, the Sustaining Land Information, or the PICOR. Somebody wants to ask a question? No? The PICOR conference, you can find details of that conference on the ASPRS website. In addition to the conferences, we are working across the stakeholder community here to foster relationships like we are having with GITA to promote the sustainable and safe use of UAS in Earth imaging and mapping and remote sensing. We have recently been requested by or invited by FAA and the AOPA, the Airline of Association of Pilots Association, to contribute to the rulemaking efforts that's going on at the FAA for beyond line of sight operations, and we'll get into that in a little bit. What BLOS means, beyond line of sight. We're also working to establish calibration and test ranges for UAS systems with the test sites that's been announced by the FAA. The first one of these will be constructed at the Stead Airport at the Nevada test range here, and it should be ready by the time that we have a conference in October. And then, of course, we promote and develop standards for mapping and aerial photography, and we already talked about the conferences. So that's about some info about ASPRS. So, Geomatics. Why are we trying to expose you to this term? We are, as Talbot already mentioned, a heterogeneous community, all now trying to do Earth imaging or observation or mapping in some way, shape, or form. Some people more experienced in that activity than others, but we're also seeing that many of the people promoting UAS, selling the systems, are making claims about accuracy, what you can use these systems for, and so on and so forth. And we are having people, some of them not familiar with the science of mapping, the science of measurement, which is, in essence, geomatics. And they are trying to use these things in mapping applications. So our objective here at a minimum is to give you that word if you are not familiar with surveying, or those words, surveying, mapping, remote sensing, photogrammetry, which is encompassed by the bigger term geomatics, that you can go look up on the internet and hopefully be driven to ASPRS and a few universities and people who know about this, so that you could reach out and gain the knowledge and the education that you need to understand how to make the systems that you are investing money in here do the best that it can for you, and that you don't shoot yourself in the foot by not understanding that. So it is a science and a discipline that underpins the UAS-based mapping, and we are really reaching out to give the community as a whole an understanding of this. So next term that some of you may know of and some of you may not know of is the term photogrammetry. It is one of the legs of geomatics, if you will. And so just talk about this for a moment. There are, what is photogrammetry? We've got the definition here on the board. But if you want to measure the size of an object, you can go and measure that object directly if you can get to it. If you want to measure the size of many objects or determine the shape of the Earth, it's a different problem. And therefore, photogrammetry, taking photos of stuff, remote sensing, I'm mixing terms here, comes into play. So if you know the scale and the location of a photograph, and I'm talking very simply here, very basic, then measurements can theoretically be made from those photos. For example, from a photo, you can get qualitative data. Let's say you're taking a picture of a house. You can see that the house qualitatively is an old house. The walls are colored, let's say, a certain color, and we call that process photo interpretation, or can call it photo interpretation. On the other hand, if you want quantitative data about that object or the house that you took a picture of, then, for instance, the size of the house, the height of the walls, the area that it covers, and so on, from photo measurement, then that is what photogrammetry allows us to do. So it indicates, photogrammetry is the science of measuring from photos, simply put. And we can, of course, try and explain how we can do this by mimicking our ability to see stereoscopically as humans. We can see stereoscopically as humans because our eyes are getting slightly different images of an object or the environment we're looking at, because they are set apart, and we can use the mathematics that supports that to describe why we can see stereoscopically, and I'm not going to go into that. So, in general sense, if we have a photograph of an object taken from different angles, if you will, we can use those sets of photographs, whether they are taken vertically, which is a vertical aerial photography, or obliquely, like you see with the house over here, close range photogrammetry, where the camera the plane is 90 degrees to the surface of the Earth, or the plane of the Earth. Sorry, no plane in the Earth. So there's the two types of photogrammetry there. And you are all familiar, or a lot of you that's been playing in this game are familiar with software such as Datum's Evolution Photogrammetric Suite, or the Agisoft suite that is out there to process UAS imagery. The underpinnings of those softwares are steeped in the science of geomatics and photogrammetry. So now that we know what geomatics and photogrammetry is and why it is important to us to understand, let's step into talking a little bit about UAS. So, if we go into the there are many, there are many definitions or interpretations of the term UAS. Some call it an unmanned aircraft system. Some call it an unmanned aerial system. We are not really concerned about what the actual definition is that somebody tries to use there. But if we look into the legislation of the FAA, then they describe a UAS as devices that are used or are intended to be used for flight in the air with no onboard pilot. And we see the unmanned component, the U component in here, and we go, so what does that U mean? We've got this definition that says there's no onboard pilot, but if we look at the pictures that we've got on the screen here, we see a lot of people. The point we're making here is that these UASs are never without people in the way that we envisage them in the near future for our use. So there are observers and operators that are key components or key elements to any UAS project or operator. There's the platform, the truck, if you want to call it that carries the payload. Payload can be a camera or a gas sensor or a chemical sensor. And then there are the ground control systems, and I've got this squared here, ground control system squared, because there are two pieces here that you need to consider. One is the system that you use to program the operation, the flight of the UAS itself. The other is the ground control system, if you will. What control do I have to achieve the accuracy that I want in my mapping project? And it's, strictly speaking, not a ground control system, but it's something to consider, and we'll get into that. The support equipment, as you can see, depending on the UAS, and we're going to get into the different types of them, can become quite cumbersome, or it could develop a large tail. Here we're looking at a Scan Eagle that's being launched, and you can see there's a launcher, there's a trailer and a truck and antennas, the communication infrastructure, and so on and so forth, to support this whole operation. If we talk about the marine environment, we've got boats of different types. We've got the boat from which we launch, or the ship from which we launch, and then the dinghy or the rubber boat from which we go collect it or recover it once it lands on the water. Over here on the right, we see some antenna infrastructure to ensure longer range communications in a project. By the way, all these pictures that you see on the screen comes from the test range up in Alaska. And then, of course, there is the geospatial information infrastructure. If we talk about UAS in the geospatial world, that you need to be able to process these imagery, exploit it, and then distribute the products out to your end users at the end of the day. So now that we know the components, let's step into the platform here quickly. What does a platform consist of? If you look at this picture on the top right here, it could be what? Is it a UAS? Is it a model airplane? Is it a UAV? Who knows? In this case, it's all of the above. It just depends on what you got on the inside. And if we look on the inside here, we have a flight control system. In the back, in this model, there's a GPS, there's an IMU, there's a pitot tube. That all combines to control the flight of this, or the operation of this unmanned aerial system. It's got a sensor in it. And then, of course, there's a propulsion system, and that's the engine. There are different types of airframes. There's a fixed wing airframe, delta wings, there are quadcopters, there are single rotors. You can find all forms, shapes, and sizes of these things, and we won't go into all those details. But very importantly, as we'll see as we go through the presentation, there needs to be a sense or a detect and avoid system component to this. And in the small UAS sense, those are typically human. And in the bigger systems, the Predators and the Global Hawks and things like that, and the future systems, we will have automated systems or onboard systems that'll do that task for us. Keep this in mind, because you'll see as we get into the operational mode here that sense and avoid becomes part of the operational envelope of the system. So,
Pierre, this is Talbot. Just a quick note. We've got about 20 minutes remaining. We want to make sure we leave some time for questions.
Right. Okay. So we can see that we've got different nomenclatures for these systems, and that it differs from the military world from whence it comes to the civilian world in which we operate here mostly. Various classes of these things, from micro to heavy. You might not think that a Boeing can be unmanned, but they can. So the important thing here, when we talk about UAS to one another, we need to clarify the context. If I'm talking to somebody that comes from a military world, they could be thinking something like a Predator or a civilian version of a Predator. If we talk into our general community here today, and we're talking about small UAS, then we can be talking about a DJI, a Phantom, or some other system like an EB or a Trimble UX5 or something like that. So very, very important. Clarify the context in which you are using the term UAS, because there are so many different capabilities that are spread across the different systems out there. So payloads we're mainly talking about imaging here, so different types of cameras that you can put on them. You can, from the electromagnetic spectrum, we can get color, visible cameras, infrared cameras, thermal cameras. There's systems out there that can carry LiDAR now. We have multispectral cameras that you can carry on these things. So the ground control system. This is what allows you to program these systems to fly certain flight paths and to capture imagery in a certain way. A very important point that we need to make here is that you need to know your system thoroughly when you program your flights. You cannot assume that you can take it out of the box and throw it in the air and fly it. You need to know what's going to happen when things go wrong. You need to make sure that you get the right altitudes programmed into your system for the fail-safe component of this, so that when something goes wrong, you don't lose your system. Very important to do that. So different ways you can control these systems. You can have direct control of the vehicle, like an RC aircraft. You can do easy RC, where it's not so difficult to fly it. If you want direct control, we call it fly-by-wire. You could have payload control different from platform control. You could have a system that runs on an autopilot, which most of us has and will have, and then autonomous systems. And you can have operational control where you've got control of the system except for takeoff and landing. All right. The way that we foresee availability for us to operate these systems in the near future would be visual line of sight, which means you will have eyes on the aircraft from your location where you're operating it on. You can go look up the definitions for beyond line of sight remote split operations on the website as well. And you'll see in these pictures that we've got a pilot in command, the PIC, and we've got an observer that's supporting him. Sometimes we'll have a third person that helps us do that. So be aware of that. Types of missions we've flown, typically two. One will be the mowing the grass, where we take aerial photography. Other one would be a surveillance type thing, or a search type pattern, where we fly around to see what we can see. So this is not new. And the statement at the top here is very important to us. Winston Churchill. We are, in certain aspects, in the same mode that we were in photogrammetry, let's say, I'm going to get the years wrong here, but let's say 25 years ago perhaps, or 20 years ago, where we didn't have all the accurate GPS, IMU, that type of stuff on board in the aircraft today. In the smaller UAS systems, we have GPS and IMU, but they're not accurate enough for us to get real accurate positioning just using those systems. So we've got to harken back to the rules of the road, the basics of photogrammetry and geomatics, to understand what we need to do to get the products that we want at the appropriate accuracy. And then, of course, aerial imagery isn't what it's supposed to be. There's a whole host of things that we could use to get imagery of objects from here, from satellites down to handheld equipment that needs to be fused. So you're never only stuck with only a UAS as your option. So there are some use cases that Talbot highlighted to us here that he'd like us to review: mapping, inspection, chemical sniffing, and so on. We won't go through all of these, but some of them, and present those to you. When you make a decision on what remote sensing tool to use, there are things that you need to consider. You've got to understand your requirements. And part of those requirements are, what is it that I'm trying to see? At what resolution? How accurate must I be able to measure off it? How frequently do I need to go back and get that imagery or that sensing done? How quickly should the product be delivered out of this? And how accessible should it be to whom? The end product, which speaks to how the data is analyzed and analytics is done. And finally, you tie all these things together and you come up with how much it's going to cost me, and is it going to make sense for me? So keep that in mind, that UAS is not always your answer. However, assuming that it is in this case for disaster response, our system that we'll use for disaster response is something that needs to meet our priority information requirements, in which it's primarily, usually, always delivering high-confidence, actionable information within acceptable timeframes to a command community. And here, our sensors and the type of platform that we use need to be chosen to support this purpose. Now, if we move on to examples of inspection, we're looking at...
Pierre, it's Kev Gamble. Can you hear me?
Yes.
Yeah, sorry. I just want to highlight here a really distinction is, as you were saying, you could pre-plan the missions with the GTS, or you can monitor them. But in all of these use cases, that's the question you have to ask, is whether this mission is going to be pre-planned and you're happy to just sit on your hands and you'll get the imagery back afterwards, or whether you want to be able to actively monitor the mission and affect its orbit, etc.
Right.
And for example, many of the inspection tasks, for example, the pipes that you're looking at there, top left, you would want to zoom in on ones that appear to be cracked. So you want to have an active data link operating one-on-one. But for pipeline monitoring, you might be able to just take the imagery autonomously, download it, process it after the mission, and then you can decide, oh, that area looks bad, let's go and visit that tomorrow. Search and rescue, you really probably do want to have somebody attached, because if you do see something interesting, you don't want to wait 2 hours to find it, you know, to try and go back or send a team in, so they may have moved or died. Just want to throw that in. I'll go silent and deep again.
No. Thank you, Kevin. And this is exactly the segue that we needed into this slide. You described it. I'm not gonna spend more time on this slide here. When it gets to the mapping part of this, where we do, you know, you're familiar with ortho photography, ortho imagery projects, mosaics, terrain models, and those types of things. You really have to understand how big the area is that you're trying to cover, at what accuracy you want information out of this from a qualitative and a quantitative point. And that determines what choices you make in the ConOps or the plan that you put together to capture this. So as you can see here from UAS, it's quite possible to do a orthomosaic and extracted terrain model from that imagery at the design accuracy level that you want out of this, assuming that you've put the right controls in place. So from a project consideration point of view and a mapping concept, what do you need to know? You want to consider how big the area is that you are trying to fly. You want to consider your accuracy, as I mentioned, and that'll help you decide what type of camera I need to take. Do I need a metric camera, or can I take a consumer camera? Do I have to calibrate that camera? How accurate is my GPS on the system that I'm using? And if it's not as accurate as I need it to be to get the accuracy levels that I want out of my project, then I need to start considering putting control down, pre-marked or post-flight photo control, photo identifiable control that you can do at the end of the day. And it's very important here, the key point with this is understand the basics of geomatics, understand the basics of photogrammetry, so that you can run this process very similar to what you would do for a manual, or not for a manual, for a manned aircraft aerial acquisition project today. And you know what to go look for, you know where to find us, you know where land surveyors are. We know this process, it works, it exists, it needs to be applied to UAS-based mapping. And I'm not going to spend too much more time on that. So, again, to recap here, you have many options, but you have to decide which one of these options or combination of those will suit your purpose, and is UAS an option for you. To do that, it's kind of a strategic decision, if you will. Don't want to make this complicated, but typically the drivers for accepting technology or implementing technology are these. It's got to accelerate your core business. It's got to, you know, improve your productivity. It's got to improve your project service, your customer service, versus the military traditional drivers, because, you know, dull, dirty, night, and dangerous, I think you all heard that before, is what the military drivers typically are for UAS. Lately, you know, people do this because it's cool. That's not a business driver. And green is typically one, but I think, you know, you need to think about the way you implement this and whether you want to do this using these drivers. So, on to the FAA. Why is the FAA concerned about this, and why should we be concerned about it? They are looking forward, and they're saying, what is the next generation of the air transport system going to be? And the term that they use for that is next gen. Their primary concern is safety. Safety, safety, safety always. You can get all the information you need about the next gen process right here at this URL, which you can find on our UAS.asprs.org website as well. But they are dealing with different types of airspace. You saw the different types of UASs that operate, you know, in different airspaces. Some can fly low, some can fly high, some can fly only in general airspace, some flies high with the jets. You, as an operator, have to understand what the rules of the road are. Unless we get that in place and make sure that everybody who operates UASs have a clear understanding of that, we probably can't have a safe operating environment. I'm kind of making a general statement as a pilot myself here, right? So here are the building blocks for integrating your UAS or a UAS into the NAS, the National Airspace System. This I get from the FAA. Not this particular slide, but the building blocks. 3 things they're looking for. System's got to be airworthy, the crew's got to be qualified, and you've got to operate according to the specifications for that system that you've got out there. And then they provide a supporting infrastructure here where they give us the ability to go declare or test that your system is airworthy. Get licensed so that get the crew's licensed. Get the operating standards defined, checked out, agreed to, and certified. And the same with sense, detect, and avoid systems and the equipment that you have on the systems. So that's the basic building blocks of getting a system manned or unmanned into the airspace. On to model aircraft operations. And people ask me, so why are you talking about model aircraft here? The reason we've got model aircraft here is because a lot of us in this community have latched on to the fact that these things are small and they're probably model aircraft, so we can use the rules that, or people want to use the rules that apply to model aircraft. That has become a problem for the FAA because people were trying to do commercial operations from that. So what they then did is they clarified their policy and they outlined in 2007 what a public aircraft needed to get into the airspace, what a private aircraft or a civil aircraft needed to get into the airspace, and then they spent a lot of time on the model aircraft operations, which was redefined here recently. And so there are very clear, if you read the interpretive rule, there's a link again from the ASPRS website to that, to define what you can and cannot do with a model aircraft. And there's a comment period out there for people, hobbyists and so on, to comment on this until the 23rd of September. So how does...
Oh, Pierre, can I just jump in here? You know, I saw something on it. But the point is, this was the FAA preemptively making assumptions that they aren't necessarily qualified to do, or even legally empowered to do. And the FAA's voluntary, the list of requests and issues and questions about it had topped over 25,000 by the time they closed it after 1 month. So I'm just saying this. I know we aren't FAA backing, and we are looking to follow the regulations, but I think it must be clear that this is a lecture unto itself, and the FAA's stance, the regulations, and the current case law is something of great interest to people that are involved. And the model aircraft people are gunning for blood from the FAA because of their so much interpretive regulation. I'm done.
Very good, thank you. So there are three ways that you can get into the space, of course, according to what's on the books at the moment. And like I said, and Kevin also said, you know, we're not lawyers here. But, you know, as you're a public aircraft, you can get a certificate of waiver or authorization. Typically public safety agencies, universities, and so on. If you're a civilian aircraft, you got to get an airworthiness certificate, and you got to get or can get exemptions. Model aircraft, very, very different. Well, we're very clearly outlined what you can and cannot do here. And I'm not gonna read through this for you, but you can again find this link to what you can and cannot do on the ASPRS website, or you can go to faa.gov.co.uas. So, in addition, we have the test sites out there, 6 test sites that's been approved to allow those people that are interested in getting system certified for operations in the airspace to go work with these guys and these test sites to get the systems tested, to the concept of operations worked out, to get all those types of things squared away so that you can submit it to the FAA for certification and the issuance of a COA or an exemption certificate or so on. Again, go to the FAA website and read about this. There's a link there that you can get to of ASPRS again that speaks to each one of these test sites and how you can interact with them. And as I said before, we are working with the state of Nevada at the moment and the University of Alaska at present to get some test ranges out there for, and also with the Griffiths International Airport. Kevin and Ed is involved there to get some test ranges and calibration facilities out there. Right. So how are things happening today? And Kevin can jump in here as well. At the moment, we're seeing that some folks are following an authorized process as defined by the FAA. Some folks are following the unauthorized rules, or not unauthorized rules, but they're following a, you know, quote unquote, unauthorized method to get their systems in the air and to operate commercially while FAA say they shouldn't. The same thing happens offshore.
Well, sorry, Pierre, only because it is physically impossible to do any operations outside of 2 small areas in Alaska that are commercial. There is no other FAA authorized commercial operation. So if any of the operators or individuals on this call want to operate it now and they want to follow the FAA unauthorized route, as you said here, then that is their only option unless they're working in northern Alaska.
Right. The bottom line here is we're not prescribing, we're not telling you what you can and cannot do, we're not saying who is right or wrong, we're telling you what's on the books. At the end of the day, your decision is based on what exposure or consequence you can bear as an individual or an organization, and we'd leave you with that thought. You know, when you make your decisions on how to operate these things and when to operate it and where, keep safety in mind, but also keep in mind, you know, what is the exposure that you think that you're going to be exposed to and the consequence of something going wrong. And with that, I think I want to summarize. As always, safety and responsibility is foremost. UAS is an additional arrow in the Earth observation quiver. And assess each use case. Unmanned solutions for mapping specifically, or for large-scale surveillance or search and rescue is perhaps not always the best solution or the better solution or the less costly solution than methods that exist at the moment. So with that, I'm going to end, and if there's time left for questions, we will take questions.
Thank you very much, Pierre and Kevin and Ed. We do have time for some questions. The first comes to us from Len Bundra, and he's asking, are the FAA rules different for local government, and that would be police, fire, zoning, utilities, et cetera, versus commercial versus hobbyists?
Yes. I wouldn't say the rules are different. If we go back to this slide, let me jump back here. You have to have, hold on.
Yeah, keep going. It was about one more forward, I think. One forward.
Let's just stay here. You have to have an airworthy system with a qualified crew operating according to written standards and procedures. Now, when you're a public agency like law enforcement, or let's take law enforcement, you have the ability to self-certify the airworthiness of your system, and the same thing with the crew. And you've got to, but you still have to do all the paperwork that supports that and describes how you're going to operate it. When you are a civil or a commercial company, all these things need to be in place, but there's different ways to get there. You want to comment on that more, Kevin?
Yeah, and especially if you could dial in on maybe the model aircraft type of systems.
Okay, so the model aircraft type systems is right here. What can and can you not do with a model aircraft? According to the latest interpretation of the rule that they have out there, and it says it here. Fly at a model aircraft club that is part of a national community like AMA, right?
I think the key is the last one, that don't fly for payment or commercial purposes. I mean they define commercial purposes even if you're in a not-for-profit. Right. They try to shut down a guy that was doing free search and rescue operations. They were subsequently thrown out of court for it, but it's that distinction which people that haven't dealt with the FAA before, even in manned aviation, don't realize how absolutely barking mad it is, right. But it has been established. I can fly a Cessna with somebody on board, and as long as he only pays me for fuel, I can fly with a private pilot's license. If I fly and I charge him $10, that is a commercial operation, and I need an entirely different license. I need to be authorized as an operator. It's brutal. And that is what they're applying the same rule. They say you can fly your model aircraft, but if you get a photograph and you charge someone $2 for it, that's a commercial operation. And that is currently banned by the FAA, even though they haven't actually written the rule. They just say it's banned, but it hasn't gone through the rulemaking process.
Yeah. The other thing here as well, go to our website in the glossary section there and go look up. We've taken the definition of hobby and the definition of recreational as they have put it into their interpretation here. And they are when I met with Jim Williams, 3-4 weeks ago now, and they're very, very clear on defining what a hobby and recreation is. And you can find that in the Merriam-Webster dictionary because that's what they use, or you can go and find that same thing on the glossary at UAS.ASPRS.org. Talbot, do you think this covers the issue sufficiently?
I do. I want to move on to Phil's question, and actually I want to take a first crack at answering it. Phil is asking, is there a need for UAS curriculum in existing GIS programs? And I would say, as the director of the GIS Center here at Delta State University, absolutely. In fact, there is a tremendous need to start talking more in GIS curriculums, not just about UAS, but the related issues to surveying and photogrammetry. We here have redone our curriculum to include information about UASs in partnership with our aviation program here on campus. Delta State has a mini Air Force of about 23 aircraft, and to teach a course specific to photogrammetry and to bring some of these things about. But there's no nationally mandated curriculum for geospatial technologies, let alone certification or credentialing. So this is something that GITA has picked up on and that I'm discussing through my role as a member of the National Geospatial Advisory Committee. That said, I certainly don't know what's going on across the country, and there's obviously tremendous interest. What are you guys aware of?
I agree with you. There is definitely a need for this to get the education out there. At ASPRS, on the UAS working group side, or the PDAT side, that's one of the topics we're currently looking at. I know that I've had, many of us at ASPRS have had meetings with various universities throughout the state and the country on this exact same topic. There was a meeting last week actually here in Huntsville, Alabama on that topic with a number of people and where we explored the same thing. I concur with you in that it's not only about the UAS topic itself, but there needs to be a reinvigoration, if you will, of this whole education on geomatics in the broad sense, photogrammetry and specifically, and how that applies to the various things that people want to do with UAS. So there are schools, Middle Tennessee State University, some community colleges up in Ohio, different places that already have curricula going. Some of them in partnership with some of the providers of software or of systems themselves. We see the same thing coming out here of the Program Executive Office for Army Aviation or Unmanned Systems here in Huntsville, where they are starting to think about, how do we, when we transition people from the military world into the new world or into the private sector, how do their certifications that they held in the military stack up or are applied in the private sector? And I know Ed Freeborn, who's on the call, is very passionate about that. So it's definitely something that needs to get a lot of attention and really quick.
I'm trying to figure out how to unmute Ed, but while I do that, Scott has a question. Says, can you comment briefly, and we've got about 3 minutes left, can you comment briefly about commercial UAS implementation outside the U.S., and to what degree is the FAA limiting the use of this technology in context of the global marketplace?
Well, the limiting technology in context of the global marketplace, I think, goes back to an ITAR question, is how, ITAR is how we control technology which we believe is sensitive going out into the international world. And I'll leave it at that. There are commercial operations in different parts of the world that some of them I'm familiar with, some of them I'm not. You can see some, if you go to the news section on uas.asprs.org, you will actually see some recent announcements out of China about them issuing the first licenses for UAS pilots, if you will, for commercial operation, and they're going to issue 45 more. So I don't think we've got enough time to talk about all that other stuff that's going on offshore, but people are welcome to contact me and we can take that offline.
Okay, and Pierre, could you flash up on the screen your contact information just so folks can know how to get a hold of you? We thank everybody for their participation today and for ASPRS for joining us at the hip to make this possible. We look for everybody on the call. Please, if you're not a GITA member, please do join at gita.org. Your membership enables us to continue to bring high-quality content like this to the geospatial space. And please do join us for our next webinar on September 16th. Look for an announcement coming out via the News Hub, or attend one of our upcoming conferences and meetings. Again, thank you for your time and attention, and a tremendous shout out and thanks to Kevin, Ed, and Pierre for taking the time to put this together. We hope to see you at one of our upcoming meetings or at the UAS Symposium in Reno.
Thank you, Gita. Thank you, everybody. Thank you, co-presenter.
Yeah, thanks, Albert. Excellent work. Yeah, thanks.
Bye-bye.